everybody, this is Karim from Mathemagic, and in today's lesson I'd like to cover logarithms. Now logarithms seem super hard because there's this word which is a really hard word, logarithm, and it sounds a little bit like algorithm and it sounds so complicated, but it really is not that bad. Okay, so today we're going to try and debunk what logarithms are a little bit and make them easier to understand, but it's a very short format, and in this short format I think you can gain a lot from actually understanding logarithms as a general thing without going into a great amount of detail, just based on a few general concepts. And I wish that people had explained logarithms to me that way when I was growing up, so I hope that I can share that with you now. So here's my take on logarithms. So don't worry, make sure that you understand everything that we're doing and make sure that you take a few notes and you should be okay. Okay, so first of all, we have some log laws. Logarithms are really inverse functions of power functions. So power functions are things like 2 to the power x, 3 to the power x, and maybe 10 to the power x. Logarithms are inverse functions of those. So they're very slow functions, a little bit sluggish like this, whereas power functions grow exponentially and very, very fast. But just like power functions have power laws that they follow, logarithms have log laws. And so here are the 3 log laws that you need to know. If you add 2 logarithms, so in the same base, so when we say log, we mean log in base 10. So I'm not going to say anything about bases just yet, but we're going to talk about it a little bit later. So log in base 10, so log of a plus log of b, is log of AB. So when you add the 2 logs together, you multiply what's inside here, right? When you do log of A minus log of B, it's actually log of A divided by B. So this is very much like power laws. When you divide, it's subtract, or when you multiply, it's added. Here it's kind of the inverse operation. When you add, it gets multiplied, and when you subtract, it gets divided. So it's exactly the same thing as your power laws, but they're called log laws. Log of a to the power x is x log a. What that allows you to do is, if there's a power to a number, you can drop the power in front. Now this is very, very useful to do what we call solve log equations. Now I've mentioned very quickly in passing that we talk about base. Okay, so this is how we speak in terms of logarithms. Log, and if you see a little 2 here, we say log in base 2. Or if we see a little 5 here, we say log in base 5. And here there was nothing, so we just said log, but it means log in base 10. So we're talking about powers of 2, powers of 5, powers of 10. And sometimes you'll see ln. Now ln is what we call the natural logarithm. And so ln x, or some people say ln x, is log in base e of x. And e is a number, a little bit like pi. It's 2.71. So it's log in base 2.71 of x. It's a very special number in mathematics. We use it quite a lot. So let's see how these log laws work with some simple maths. As I said, not very difficult at all. Log in base 10 of 5 plus log in base 10 of 12, well, they're added, so I just multiply those two, is actually log of 60. And log in base 10 of 5 minus log in base 10 of 12, well, that's minus, so that's just divided. It's log of 5 over 12. And here I have log in base 10 of 5 squared. Well, I can drop the 2 in front. So I can say it's 2 log 5. Now that could be quite useful, especially when we solve power functions and power equations. So, so you're always allowed to drop the power in front. Log of 1,000, well, this is where logs get a little bit interesting. Since this is in base 10, log of 1,000 is log of 10 cubed. And you can ask yourself the question, which power of 10 is 10 cubed? So which power of 10 is 10 cubed? It's the 3rd power. So log in base 10 of 10 cubed is 3. So if you want to cancel log in base 10, you need to use powers of 10. And so this is quite handy because 1,000 is a power of 10. It's 10 cubed. So if I had 10,000 here, log of 10,000 would be 4. If I had 100,000, log of 100,000 would be 5. Here I have log of root 10. Now in mathematics, square root is to the power half. So log of 10 to the power half, well, that's just a half. Okay? So this is how you can deal with logs in different bases, how to simplify them using the first 3 log laws, or how to understand the bases a little bit, or which numbers can be extracted. So if it's in base 10, you can extract powers of 10. If it's in base 2, you could extract powers of 2. If it was in base 5, you could extract powers of 5. For example, log in base 5 of 25 is equal to 2, because 25 is 5 squared, right? So here's something interesting. I thought this would be a good little exercise to finish, and hopefully we understand the applications of logarithms. So I've drawn a little graph here, which is 3 to the power x, and then here on the side I've drawn log in base 3 of x. So these are inverse functions of each other. So 3 to the x goes up quite fast. 3 squared is 9, 3 cubed is 27. So if you had a question like 3 to the x equals 9, you would know that x is 2, because you think, well, 9 is just 3 squared, so the only possible solution is 2. If you had a question like 3 to the x is 27, x would be 3, because 3 cubed is 27. So these are those two solutions. But if you had a question like 3 to the x equal 15, well, you'd be hard pressed to tell me which power of x, which power of 3, sorry, is equal to 15, because it's not like it's a whole number. There's no whole number which you can put as a power of 3, which is going to return 15. So you're going to have to do a little bit of work here. But of course this value exists, and it's got to be between 2 and 3. Because 3 squared is 9 and 3 cubed is 27. So there's got to be a value here that's equal to 15. It's got to exist somewhere, right? So we're looking for this. We're thinking, so it's probably a number between 2 and 3. We just don't know what it is. So how can we find it? Well, this is where logs are very useful. We use logs to solve power equations. This is a power equation. So what do? Well, I can use log in any base, it doesn't really matter. Here I'm using base 10, I could use ln, I could use log in base 3, it doesn't really matter. So I log both sides. So I can say log of 3 to the x equals log of 15. Now why would I do that? Well, because of this law, which allows me to drop the power in front. So once I have log of 3 to the x equal log 15, I can drop the x in front and say x log 3 is log 15. Well, that's pretty cool, because log 3 is a number, log 15 is a number, and I can just move log 3 to the other side, so times becomes divide. X is log 15 divided by log 3, and if I enter that on my calculator, I find that it's a number pretty close to 2.5. So there is a number here, and if I was to type in my calculator 3 to the power 2.5 or 3 to the power 2.49, I would find that it's about 15. So this is how you use logarithms to solve power equations. I know this is a lot to take in a very short lesson, so I recommend that you do some exercises. If you'd like me to upload some PDFs, perhaps I can. You can contact me and I can put them in the description or in the comments box. You can also find some PDFs online to work with logarithms. There's a lot of worksheets for you to do online. I'm primarily uploading these to give you the lesson content. So if you'd like to follow up with some worksheets, you can do that as well. Now I'm going to make this a new tradition to finish off with a really, really terrible maths joke. So here it is. No cringing, right? Only silly jokes here. So if you'd like to follow us, you can find us on Instagram at MathemagicMD, and you can also follow us on Facebook, facebook.com/HLMathemagic. Remember, logarithms don't have to be all that scary as long as you understand your log laws. So until next time, please make sure to subscribe and follow, support our channel. Thank you so much, and I hope this was useful to you.